Awesome. So, welcome back. Today we're going to be finishing our unit on derivatives, and we're going to be talking about the derivatives of inverse trigonometric functions, logarithmic functions, and exponential functions. So, let's get right into it. That's the last slide. Don't worry about it. All right. So, last time I believe we left off here. All right. And we covered all of the basic conceptual ideas we needed to cover about inverse functions. So the next thing to do is we have to derive the derivative of the arc sine. And the reason we talked about inverse functions last time is because obviously the arc sine is the inverse function of sine. So we had to kind of do a little bit of a review on inverse functions before we did the derivative of the arc sine, just so we were on the same page and stuff like that. So I put a note here to refer to the textbook to guide me. That's not because I forget the derivation, but because there's a, you know how like some rules have like a lot of conditions to them? Like this only works, like this rule has a lot of conditions to it that I didn't memorize. So I just have to make sure that I'm not missing any of those conditions. Because it's just like, it's just a lot. It's not like a lot, but it's like more than I thought worth remembering. So, all right, here we go. All right. I'm just going to have it on the floor and like look down periodically. Okay. I know the general process for how to derive it. I just need to make sure that we have the same conditions. And the way we're going to derive arc sine is using implicit differentiation. So that's why yesterday was very important to get that mathematical thing under our belt, because now we can do some cool stuff. All right. Okay. So I'm going to write the arc sine function. F of x equals sine inverse of x. All right. And remember the notation we talked about in unit 1, that this means the same thing as this.
Yeah.
All right, they're just different ways to write the same thing. All right.
Yep.
So here's the arc sine function. And I'm going to call it either arc sine or inverse sine. They're the same thing. All right. So I could write the arc sine function as y equals sine inverse of x. Right. And if I took the sine of both sides, right, I'm just doing the same thing to both sides, right?
Yep.
What happens when I take the sine of this side?
It cancels out.
Exactly. So I'll get sine of y equals x.
Yep.
Would you agree this is the exact same equation that describes the arc sine function?
Absolutely. Yeah.
We just have to remember that we're in the arc sine function. Remember, we restricted our range. Here, I forget the range of the arc sine function, so I'm just going to go into Desmos and look at it really quickly. I didn't memorize it because it's just one of those things that like it's just annoying.
Yeah, I don't have those memorized.
Yeah, so don't wait, no. Okay, so the range is from negative pi over 2 to pi over 2. Yeah. Yes. All right. So this describes the inverse sine or the arc sine function. As long as we remember that. Oh wait, sorry. The y has to be restricted. Our range is restricted. Right. As long as we remember that our range has to be restricted.
Okay.
All right. So remember. So this, you'll see why this is important in a second. Remember that the derivative of sine is cosine, right? All right. And what can you tell me about the value of cosine in between negative pi over 2 and pi over 2? Is it positive or negative?
It is positive.
So cosine will always be positive, right? In this range.
Yeah.
Or at least the cosine of y will always be positive in this range.
Yeah.
Because of the range we've defined. All right. All right, so last thing we have to do. All right, let's look at the arc sine function. What do we notice about the derivatives of the arc sine at the endpoints?
What do we notice about the derivatives of it?
Yeah, at the endpoints. Are they
going straight down?
Yeah, straight down and straight up.
Straight up?
So do they exist or do they not exist?
They do not exist.
Exactly. So the derivative of arc sine, right? Will the arc sine function will only be differentiable on this interval. All right. So even though the arc sine function includes negative pi over 2 and pi over 2, it'll only be differentiable when it's in between the two numbers, not including them. Because when it is those numbers, then we get it undefined.
Okay.
All right. I'm just looking at the conditions. All right. Got it. All right. So let's get started. So we said that sine of y equals x perfectly models the arc sine function. They're the same thing.
Yep.
So I could do implicit differentiation and try and find the derivative. Let's take the derivative with respect to x of both sides. All right. So the right side is probably the easiest to do. All right. Can we simplify the right side first? The derivative of x.
Is it just 1?
Yeah.
Yeah, okay.
Okay, cool. The left side is a little harder, right? Because we have these y's here, all right? And remember, the chain rule tells us that if we want to find the derivative of y with respect to x, right? We take the derivative of y with respect to some other variable times...
And then that variable with respect to x?
Yep. Yep, exactly.
So then what variable would it be right now?
So we're trying to find the derivative of sine of y with respect to x, right?
Yeah.
So would you agree that the derivative of sine of y with respect to x equals the derivative of sine of y with respect to y, right?
Yep.
Times the derivative of y with respect to x.
Yes.
Cool.
Yeah.
What's the derivative of sine of y with respect to y? They're the same variables, so we can just use the derivative we know.
I'm not sure. My brain feels a little bit fried right now.
No, that's completely okay. I completely get it. So remember yesterday we said the derivative of sine was cosine? So the derivative of sine of x with respect to x is cosine of x?
Yeah. Okay, so then it's the same thing, so it's just cosine y?
Yeah, exactly.
Cool, okay.
So the derivative with respect to x of sine of y is cosine y, right? Because that's the derivative of sine of y with respect to y. But then we have to multiply it by dy over dx, because we have to multiply it by the derivative of y with respect to x. That's what the chain rule tells us.
Okay.
All right?
Yep.
So we can say dy over dx equals 1 over cosine y, just by dividing both sides by cosine y.
Okay.
And this would be a perfectly valid expression for our derivative. But remember, we've defined the arc sine as a function, right?
Mm-hmm.
So if we're trying to find the derivative of a function, every single derivative we found expresses the derivative in terms of x.
Yeah.
So we should try and write this derivative in terms of x as well if we're going to make it a function. All right?
Okay.
And here's where the idea that cosine is positive is really important. All right.
Mm-hmm.
So there's a trigonometric identity. All right. That the cosine squared of theta plus the sine squared of theta equals 1. Do you remember that one?
Yeah. Yep.
So then cosine squared of theta equals 1 minus sine squared theta.
Yeah.
So then cosine of theta, equals the square root of 1 minus sine squared theta.
Okay.
Right?
Yeah.
And if, actually we'd say it's plus or minus, right?
Yeah.
Because we're taking the square root. But remember, on the interval we've chosen, the interval the arc sine is defined, all right? The cosine is always positive.
Yeah.
Right? So we can say that the cosine of theta is just equal to the square root of 1 minus sine squared theta. Because it's never going to be the minus. It's always going to be the positive. All right?
Okay.
So we could then replace cosine y with the square root of 1 minus sine squared theta, or sine squared y, right?
Mm-hmm.
The cosine of y equals this. We follow that?
Yeah. Yes.
But remember our original equation, we said sine of y equals x.
So then is this x squared?
Yeah, it's 1. So then dy dx equals 1 over the square root of 1 minus sine,
Just x,
yeah,
right?
1 minus x squared.
Yeah.
All right. So then did we express our derivative just in terms of x?
Yeah, we did.
Did we set out to do what we wanted to do?
We did.
Cool. And that's the derivative of arcsine.
Damn.
Using implicit differentiation.
Let's see. All right.
And additionally, I will note that, remember, we divided by cosine of y. But remember, we said that our function only has a derivative, right, when y is in between these two things, but not equal to these two. So in between these, but not equal to these two, the cosine is never 0.
Okay.
So that's why we can divide it by cosine y and not worry about it being 0.
Mm-hmm.
Cool. So this is the derivative of arcsine. Using implicit differentiation. I think it's a pretty cool way to find the derivative. Like, we're using the tools that we used yesterday. We're like, it's all coming full circle.
I agree.
Cool.
I just want to write this down real quick.
Of course. Oh God, I was literally so excited for yesterday, because next we're gonna get into exponentials, and we're gonna talk about e, which I've never geeked out more about a number. It's great.
Oh boy, okay.
It's great.
We can keep going.
All right, cool, awesome. So this is the derivative of the arc sine. We just proved it. Here are the derivatives of the other trig functions. All right, and if you can write them down. If you want, we could derive each individual one, but the reason I don't think we need to is because it's the same process. I don't care if you memorize how to do each one. I just care if you know the process for doing each one. We would do the same kind of process. We'd rewrite the inverse trig functions, like inverse cosine, as cosine y equals x.
Yep.
Tangent of y equals x, and use the exact same process. All right. So if you want to derive any of these on your, if you want us to derive some of these, we can. But the reason I don't think we have to is because, yet again, it's the same process for how we did the arc sine.
Yeah. Okay. Maybe could we do just like one of them?
Yeah. Well, you can pick any one you want.
Okay. Let's do cosecant. Let me just
write it down first.
Yeah. I'm just writing all these down.
Cool. Awesome. This, you know what? I'm not going to look at the textbook. I haven't memorized how to do this. Let's see if my mathematical knowledge can do it on my own. That's the challenge.
All right. I like it.
That's the challenge. I didn't memorize any of the conditions, though, so no, I'll be fine. It's the exact same process for arcsine.
All right.
Exact same.
You better,
all right. This is going to determine the validity of my professoring. All right. Yeah. So cosecant, inverse cosecant equals y. All right.
Okay.
Here.
Wait. Actually, can I just finish writing those down?
Yeah. Oh yeah.
You good. I should write these down, right?
Yeah. I would have them down. I don't think we'll have to use them that much, but I'm going to tell you my dirty little secret. I didn't memorize these for the AP exams. I just said if I needed to use it, I'd derive it on my own on the exam.
Oh my! Wow.
So I'm so anti memorization. I'm so pro.
Like me too.
Understanding.
No, I am too.
Yeah.
I've always been that way. X squared minus 1. It's so tedious.
Yeah. Take your time.
x just to have it to refer back to the...
Yeah, just so you can refer back to it if we need it. Because if the derivative of inverse trig function ever comes up in a problem, we just have them met already.
Yeah.
Like I said, we're adding things to our mathematical tool set. It's
Exactly.
like if I'm building a house and I need a wrench and I don't have a wrench, then I'm gonna have to build a wrench to fix the house.
Yeah,
but if I already
have
my wrench, then I can just go straight to fixing the house.
Exactly.
That's a perfect analogy for what I mean.
Okay, I am ready.
All right, awesome. All right, let's see if my teaching is valid. All right, so inverse cosecant looks like this. Cosecant inverse of x equals y.
Yeah.
We could rewrite it the same way as cosecant of y equals x. Next, I'm going to take the derivative with respect to x of both sides. All right, and I'm going to get 1 on this side. All right, and the chain rule tells us if I want to find the derivative of cosecant y with respect to x, I have to take the derivative of cosecant y with respect to y and multiply it by the derivative of y with respect to x. The derivative of cosecant y with respect to y is negative cosecant y cotangent y. Let me triple check that that's the correct derivative. Yeah. All right.
Nice.
And then I have to multiply it by dy over dx. All right. All right. We could also say that this is equal to negative cosine over sine squared, or negative cosine y over sine squared y. Because cotangent is cosine over sine, and cosecant is 1 over sine. So if you multiply them together, you get this.
But then times dx over dy.
Yeah, times that.
Or sorry, dy over dx.
Yeah. All right. So then I can get dy dx on its own. 1 over either negative cosecant y cotangent y, or 1 over 1 over, or I could say not 1 over, I could say sine squared y over negative cosine y. I'm just replacing this with this. Okay. So sine squared. So we have our derivative is equal to sine squared y over cosine y. All right. Cosecant. If we say cosecant y equals x, that's the same thing as saying 1 over sine of y equals x. All right.
Yep.
So then I could say sine of y equals 1 over x.
Yep.
Next, I'm going to rewrite cosine of y as the square root. Is it plus? I think it might be plus or minus here. This is the only time I'm going to look at the thing. Yeah, I think it's plus or minus. So I can say, I could say that the sine, I could say the cosine of y equals plus or minus the square root of 1 minus sine squared y. All right?
Yep.
So I'm going to get that the derivative is 1 over x squared, because we're taking sine squared y, and sine y is 1 over x, divided by the square root of 1 minus 1 over x squared.
Okay. Wait, sorry, I sort of don't see how you got that.
Hold on, I could be doing this in, let me see, cosecant. Okay. Oh, I see. Okay, awesome. So cosine of y equals plus or minus. So remember how we said the cosine of y is equal to the square root of 1 minus sine squared y in our last one?
Yeah. Yeah.
So I'm just doing plus or minus this time because I don't know if we can ignore one of the two. I haven't done the conditions, so I don't know if we can ignore one of the two.
Okay.
All right. So cosine of y equals this. All right. Equals this. And remember,
Yep.
sine of y equals 1 over x. So the top is 1 over x squared. And cosine of y is the square root of 1 minus sine squared y. But because sine of y equals 1 over x, we can replace this as 1 over x squared.
Okay.
Okay, that's what I've done. We have a 1 over x squared here. I could just bring it into the denominator. Because when you have 1 divided by this, that's the same thing as just 1 divided by